It's now time to take a little look at the stalks of celery and see if we do see a difference. So let's start off with our control, and let's take it out of the blue dye, and let's see how far up in 30-40 minutes it was able to go. So I'll make a first cut here. Okay, and if you look really closely, you can see that there is some blue that's made its way up through the xylem. That is the water carrying part in the celery in plants. And so let's cut a little bit deeper and see if we can figure out just how far up it was able to go in that amount of time. Okay, so on the right, I still see a little bit of blue that's made its way up, so I'm gonna have to go a little bit higher. And let's see. Yeah, we still have some blue making its way up, so I'm actually gonna go a little bit higher this time and see if we can find that limit. Okay, there we go. This is about as high as it went. So if I take those pieces now and we'll lay them with each other, and we'll take a quick look here with the measuring tape, and we'll see how far it did manage to go, to travel through the xylem. So if I measure, I have about 4.5 inches is the distance that the water is able to travel through the xylem in the celery. So this is our control. We just put it in the water and we let it do its thing. Now, let's take a look here where we had some warm air moving through the leaves. So we'll take that out there and let's start to make some cuts. So if we make our first one here, take a quick look. Yeah, I definitely see red in there making its way through. Hopefully you can see with the focus there. Let's cut a little bit higher. Okay, I still have some red. So let's go a little bit higher. Yep, still red. So you can see we've already gone higher, and you can see the difference that running that warm air over the leaves has made. We do have it going up higher. And in fact, if I look carefully, I think I might see it's already reached the leaves in some cases here. I don't know if you can see that on the camera, but there's a little bit of red starting to come in through the veins of the leaf here. So I think it may have made it all the way to the top in the time that we had. Yeah, absolutely. It's gonna be a little hard for you to see on the camera because it's not focusing so great. But if we take that measurement now of our stalk that I've already did some cutting with, we're gonna see that it's gone at least 9 inches. So pretty much we doubled the results there by moving that warm air over the leaves of the celery stalk. Little change of scenery here. I am coming to you from live on board the Oosterschelde in beautiful Rio de Janeiro here in the harbor. And I want to answer those 3 questions from last 2 weeks ago's experiment on transpiration. So the first question was, how does the heat and the airflow affect transpiration? Well, the warmer it is, the more the guard cells, called stomata, on the bottom of the leaves open. When those are open, water can be evaporated and pulled slowly up the whole root and stem system of the plant to the leaves. So the more heat, the more moving air, the more evaporation, and the faster the rate of transpiration will go. The second question was, what is the difference between xylem and phloem? So xylem transports water through the stem of the plant up to the leaves. So that's what we were looking at with that food coloring. And then the phloem transports the sugar, the nutrients, through the plants. So it pulls it up to the leaves when needed, and it also sends it back down to the roots in the plants that lose their leaves over the winter. And the final question was, how does light affect transpiration? And so when it's light, the guard cells, the stomata on the bottom of the leaf, they're photosensitive, so they open. When it's dark, they close. So the lighter it is, the more they're going to open, and the faster the rate of transpiration will be.